So now what we are going to do, we will uh, re, re, recast this video again. Otherwise, it will not. There is too much humming sound in the previous video. So we'll start now. So it's very fast actually. API 5L Grade B PSI. That's what we are discussing here. It is a standard carbon steel pipe, also referred to as L245 as per ISO 3183. So, Grade B designation signifies specific set of mechanical properties, minimum yield strength, and key characteristics are it is equivalent to ASTM A106 Gr B and ASTM A53 Gr B. Manufacturing methods are ERW, LSAW, longitudinal saw, and this is a spiral saw, and it is helical saw. Okay. So the minimum yield strength is 35,500 psi, and minimal tensile strength is 60,200 psi. And when we are referring PSL2, it is strict chemical and mechanical requirements, maximum values for yield and tensile strength, and additional testing like impact test. Okay. So, common application of API 5 Grade B is auxiliary piping with refineries and petrochemicals, which we are using in Madina site pump station. So this is the application in our project. Okay. Now we discuss electric resistant welding method, which we are using in the manufacturing process, and for that it's a flat steel strip or coil. It's called formed into cylindrical shape, and the electric current pass through the edges. They heat these edges to a point that they are formed together under pressure without any use of any filler material. So weld seam will be a single straight longitudinal seam, and size range will be small to medium diameters from half inch to 24 inches. The applications medium to pressure applications such as water distribution, etc. Here 12 inches means half inches means it will be 12.7, and 24 inches which is around 600 mm. Okay. It's a video of submerged arc welding. So he can next one is LSAW, longitudinal submerged arc weld. Here individual steel plates and not coils. It is gradually formed into a cylindrical shape using like a UEOE method or a JCOE method. Means J'ing, seeing, O'ing and expanding. It is then welded internally and externally using submerged arc welding process, and weld seam will be single or double straight longitudinal seam, and size range will be large diameters, typically from 16 inch to 16 inches to 60 inches or more, with a thicker walls, and applications is for high pressure long distance transmission line, oil and gas, other hydrocarbons, and especially critical areas like across a city or sea, etc. Here is the manufacturing process, Jing, seeing, like that. First is Jing. This is the Jing. Now after that it is seed, seeing and owing is there. Now after Jing it is seeing, then it is owing finally, etc. Then this process is after completed, it is welded internally and externally using submerged arc welding process. So this is LSAW, longitudinal submerged arc welded pipe. Now why we are using LSAW joint pipe? Because it should be placed, the LSAW joint or seam should be placed in the upper half or upper quadrants of the pipe circumference, so that optimal position are often 12 o'clock position, that is top center, or staggered within the top 90-degree arc. So placing the the principle is that the it should be placed away from the point of maximum bending stress. Typically occurs at 3 o'clock or 9 o'clock positions in a trench. So it will withstand better withstand the installation on operational stresses, ground settlement, or internal pressure variations. And it is also good for visual inspection, non-destructive testing, etc. So staggering is also required, because it should be staggered or separated this when joining two longitudinal saw pipes. Standard engineering practices or codes are uh, recommended longitudinal seams of adjacent pipes to be staggered or separated by a minimum distance of at least 5 times the wall thickness of the thicker plate, or rotated by 90 or 180 degrees Celsius degrees to prevent weld seams from lining up perfectly along the entire pipeline. And should be oriented away from the bottom of the trench, avoided, because rest on when the pipe rests on a bedding material, it experience contact stresses. So to avoid branch connections also is very important, because to avoid by welding branches of directly onto the longitudinal weld mesh is very important. Now this is spirals, saw, and helically saw also. Uh, hot rolled steel coil or strip is fed into the machine at an angle of the pipe's central axis, rolled continuously to form a helix or spiral, resulting in the system welded using submerged arc welding process. So the continuous spiral seam is there running along the length of the pipe, very large diameter, ranging from 20 inches to 100 inches. 20 inches means it will be uh, 500, and 100 inches will be more than 1500 mm. So applications are used for non-critical or lower pressure applications, water transmission lines, uh, structural piling, or dredging. Manufacturing is also cost-effective production of various diameters from the same coil width. Okay, this is the spiral manufacturing process. It is the welding, spiral fed, and it is welded. Now the summary of differences. Summary of the difference is that LSA is a superior type because high pressure rating will get higher than, but the cost also higher than the spiral SSAW and the ERW. And the welding process is submerged dark. Uh, it is straight, longitudinal. Individual steel plates are there. Here, both other two methods they are using steel coil or strip. Here, individual steel plates. And diameter also 60 to 60 degree. That and here it is 20 to 100. That's the difference in the welding. But here, large diameter is possible. It is limited to 60. 60 is around 1,400 or something. 1,500. Okay, 1,500. Like that. This load calculated thickness is PD divided by 2SC plus PY. When y equals 0, y equals 0 means it is accounts, this y coefficient accounts for longitudinal stress from internal pressure or temperature variations, etc. So it's always minimal, and the y we are taking as 0. So this time is 0. So PD by 2SC will be our so here PD by 2SC will be our calculated thickness plus C corrosion allowance is 3 mm. But if for our specification, because we are providing cathodic protection, this is not required. Then T mill tolerance is T mill. It is always 0.5. It will for a margin, a safety margin, so thickness is not reduced more less than minimum during manufacturing. Okay. Now we have this. So here it is when we are considering circumferential tension stress. As per the section 5 in the I set out in the 5 stress analysis section. Here is the 5 stress analysis section. See, when you are calculating wall thickness, following loads to be considered, like earth and external hydrostatic pressure, live loads, bending stress design, deflection design, buckling design, internal pressure design, longitudinal stress design, loose thermal expansion and contraction. So pi stress analysis, that the section 3.4 is there. We will discuss during pi stress analysis section of this guideline. Now this tolerance for the thermal expansion is we discussed, because a suitable distance of unbalanced pipes of we are discussing for localized thermal expansion during welding. For that we require a suitable distance of unbackfilled pipe shall be maintained before and after welding joints to allow for localized thermal extraction during welding. Then closer welds. Closer weld means where the weld ends shall be remain exposed for relieving expansion or contraction forces during construction and normalizing of temperatures after balance. So the dead ends to be always remain exposed for relieving this. Third step is when we are giving these expansion joints, it should be located anchor points for flat pipes and on the downhill side of anchors for the graded pipes. Now, fourth one, expansion joint on the bridge crossing shall be in parallel to the expansion joints on the bridge structure itself. Fifth one, expansion and contraction induced forces on the T's to be side friction. Due to side friction, soil friction, we have to consider expansion and contraction induced forces on the T's. Then anchor rings, that the pedal flanges, shall be used where the pipe passes through the concrete chamber, anchor, ball, etc. and shall be designed with the dimensions to resist shear punching. Okay. Now we will discuss the difference in carbon content of a PFI weld. So it has similar carbon content of 0.28% for 0.26% for the welded pipes. So what will happen? This is same for both the API 5L X52 and API 5L Grade B. So 0.26 is the carbon content. It is not changing, but the manganese content is changing because API 5L X52 is a maximum is 1.4%. API 5L Grade B is 1.2%. So and the other as far as phosphorus content is 0.03%. And maximum sulfur content also 0.03%. So what happened? This only changes in manganese content. So higher manganese content in the X52 contributes to higher and the yield strength compared to grade B. Okay. So what is the difference in welding quality of a longitudinal saw and a helical saw? Longitudinal saw, they will have a higher welding quality due to a single longitudinal weld, which allows for more uniform seam, better strength and easier quality testing, in contrast with the spiral weld given to this spiral saw, because it can result in lower strength, more residual forces and a larger heat affected zone. So longitudinal weld is weld quality is single straight weld, and strength is more stronger and more resistant to high pressure. Stress experience a lower residual stresses, better stress distribution, quality control, easier to inspect using non-destructive testing, and application is high pressure, high stress applications, critical infrastructure, etc. So in the HSAW, that is helical, this is a weld quality is less uniform and therefore larger heat affected and may have larger heat affected zone and lower strength compared to LSAW, higher residual strength and can impact long-term performance and quality control, higher risk of defects like cracks, applications low pressure, non-critical applications like water distribution. So that is the difference in the welding quality of LSAW and HSAW. So what other common grade of carbon steel grades are ASTM A53 Gr B, ASTM A106 Gr B, APF5L X42 to X70. This is A53 grade for general purpose applications in both seamless and welded forms, ERW forms, gas, water, gas, oil, etc. Good strength, weldability, cost effectiveness. But the ASTM A106 grade is specified for higher temperature, higher pressure applications, usually in a seamless form. And applications are oil and gas, power plant, other demanding advantage, higher strength and resistance to high temperature and pressure. APF5 is standard for pipeline applications, various grades are X42 to X70, and applications are high strength and durability for demanding pipeline environments. So all these codes are for material codes. Okay. Other grades of pipes are ASTM A252 Gr3 used for structural applications, ASTM A333 Gr6 for low temperature applications, A335 P22 for high strength chromium molybdenum steel alloy suitable for higher temperature or higher pressure applications. ASTM A335 P11, a carbon steel pipe with good toughness and wear resistance.